Example 2 actually is a worked example of a data set of mileage, which is included in there. I think it's 100 data points or so. And now looking at some of these techniques to see whether or not it can be viewed as normally distributed data. So the first technique, the graphical one of the stem and leaf, looking at, in this case, 13.0 is our minimum miles per gallon, and then the maximum is 31.00. And in each of these we had 2 data points that fall for both the minimum and the maximum. So as we go ahead and just plot out using the stem and leaf, we get a distribution that looks somewhat perhaps like a normal, but let's not make any advanced judgments and then go to the rest of our data. So if we compute what our values are for Q1, Q2, and Q3, go ahead and plot those out. So we've got our median here at Q2, our Q1, and then our Q3, our minimum value of 13, our maximum of 31. We've now defined what our box and whisker actually looks like. Again, this was determined by taking our 100 data points, a little bit monotonous here, ranking them, determining where the cut points are for Q1, Q2, and actually Q3. The difference here, Q3 to Q1, is our interquartile range. So we're seeing this box and whisker actually has a lot of our vocabulary. It has the median, it has the interquartile range, it has the range itself actually go ahead and define. We can look at the factors of skewness. In this case it appears to be centered, so it looks like it's symmetric. It's neither left skewed or right skewed. Continue on with the rest of our data, we can go ahead and calculate what the actual summary statistics are for our data set of 106 actually, and identifying the mean, standard deviation, quartile ranges. For our next example, we want to look at, or next part of the example, we want to look at how much data falls within 1, 2, and 3 standard deviations. So using our calculated value of the standard deviation of 3.7, adding that on to our mean, subtracting that from our mean, we get a range of 17.5 to 25.1 for data within 1 standard deviation. Can go ahead and do that for data within 2 standard deviations and 3 standard deviations to identify those ranges. Once we have those ranges, analyzing the data by counting how many data points actually are within each of these ranges can show us that within 1 standard deviation we've got 75% of the data, within 2, 93, and within 3 standard deviations we get 100% of data. So there's a lot of analysis that can be actually done by looking at our data. The next test that we got is actually looking at the interquartile range divided by the sample standard deviation. We want that around 1.33. In this case it comes on out to 1.06. A few more tests to look at, and it's the graphic test. In this case what we've done is looked at the z-value versus our individual data points for our mileage per gallon, and in plotting those on out, we're going to get roughly a linear positive relationship. So if we go ahead and examine the data, perhaps one could argue that the stem and leaf looks like normal data. It looks like a normal histogram. The box and whisker clearly looks symmetric. It's what we would expect from normal data. The statistics themselves, the mean and median are roughly about the same, so that plot's positive for us. We see that most of the data is falling with the range of our standard deviations as we expect, and so that's plotting out okay. The interquartile range divided by the sample standard deviation is roughly about 1.3, in this case 1.06, and so that's plotting on through. And then finally the normal distribution, looking at the normal probability plot, the z versus the x is roughly linear. So in this case we're going to say that most of the data actually, the data looks like it has normal characteristics, and can go forward and analyze it that way. So, in summary, we introduced the topic of statistics. We looked at some graphical measures of statistics, and then finally 7 tests for normal data to see if data actually has a normal distribution. So with that, you should be all set to do the homework, and have a great weekend. We'll see you Monday.